So welcome to this course of Mahout, and Mahout, as you know, is a machine learning library, a highly scalable machine learning libraries. There are a lot of machine learning libraries and other things which exist today, but different characteristics for each of them differently. Mahout comes with direct support to what is known as a distributed computing system, Hadoop. So Mahout works directly with Hadoop, and that makes it more popular because Hadoop is used to solve large-scale data problem, and Mahout actually enriches that to give you more of machine learning capabilities on top of Hadoop. So that's the basic construct and why Mahout is becoming popular, because as Hadoop becomes popular, people have started using Mahout as well to discover and identify new patterns. But before we get there, let's look at the course content, and we'll look at what we are going to cover from here on. So overall, if you look at it, this is what the course content is going to be. We are going to introduce machine learning more from a top-down perspective to understand where machine learning really comes in, why it's important, and how is it really used in the industry today. So if you look at big data as such, big data is not just about processing data and transforming data. It's all about deriving insights from the data itself. So when I say insights, you are trying to understand the data and get some meaningful information which you can help in making decisions. So that's the kind of knowledge which you are looking from the data. So the large volume of data which exists in the enterprise, and what big data enables you is to turn that data into insights. And just turning in data into insight is not simple. So if you look at it, Hadoop only gives you processing and processing kind of capability. It doesn't give you anything enriched from there. So to get real insights, you need to have some way of understanding and inferring from the data. And machine learning actually provides you one of such capability. It is not the only capability, but it is giving you one such capability where you can understand the data and get some patterns on the data. So what we are going to do is we are going to understand the difference between data mining and machine learning, get into the details of machine learning, and look at Mahout in particular. So one of the prerequisites to this course is that you should have some high-level understanding of Java, because we are going to, as we get into the hands-on, is going to be somewhat of Java examples as well. Mahout gives a lot of command line things, but preference is we should have some understanding of Java. So to begin with, when we start off, we are going to look at what is machine learning and what is Mahout. So if you look at it, there are few things. If you look at understanding Hadoop and learning Hadoop, Hive, Pig, and other things, it's easy. You can go over the internet, search certain things, and you still be able to make to some level of progress. But learning Mahout is extremely difficult, especially because there is not enough documentation. There is not enough approaches and other things which is outlined. So this course will give you that approach from a practitioner's perspective on how you can take machine learning and how can you learn quickly get on to Mahout. So that's the first objective of this particular course, because over the learning Mahout without some hand-holding is really difficult, and which is what I had felt when I started Mahout few years back. So this is a jump start to all of those who is going to learn Mahout. So what inside Mahout we are going to cover? First, we are going to look at the fundamentals of machine learning. What really is required to enable an individual on machine learning. So the first of those is you need to understand about all the concepts in linear algebra with respect to vectors, matrices, and the utilities available which can help you do vector algebra or matrix algebra. So that's the one of the important thing which people usually miss out. They start off directly with Mahout, and we don't really get into the understanding the fundamentals of how a vector is created, how a vector gets encoded, what's really a feature encoding, and so on. So we will try to look at that in depth first, understand the fundamentals, and then go from there to see how you could actually use these fundamentals to deploy machine learning. The next very important step in machine learning is preparing your data. So you're taking any raw data. It could be textual, it could be categorical, it could be key values, and so on. But how can you take that data and prepare the data is going to be another very important step. So the preparing the data set is another area which we are going to cover. What are the different techniques and stuff like that. Great. Yeah, so what we are going to do here is we will help you prepare the data for machine learning. So that's going to be what we will outline. And then the next thing which we are going to go ahead is going to be with respect to the individual algorithms which are available in Mahout. So we'll start with either recommendations or classification. So this is in no order of how we go about, but each can be taken as independent item. So we can start either with recommendations or classification. So in recommendations, we are going to look at user-based recommendation and item-based recommendation. And what is really a recommendation? I hope you know that it is basically saying that, yeah, if I went to a website, I have made few clicks on the website. Immediately the next click before I make it, the website has given me something which is very relevant and what I was looking for. So it's more like a contextual offer which the website makes to me is one example of a recommendation. You could look at that and explore it in any number of forms where it is more like the system telling you by understanding your behavior like what you would really do next and helping you guide through that process. So that process of identifying what a user would really do next is basically predicting that and it's one of the field of recommendation. So there are two types of it where you do an user-based recommendation or an item-based recommendation. User-based recommendation tries to find out users who are similar to that particular user and say that, yeah, this user seems to be similar to this user, and after this user has done these few things, he has done this. So why not I suggest this particular item for that user. So it's based on a user-to-user similarity. While the other one is on an item-to-item similarity. For example, let's say I bought a Hadoop book. So there is a natural choice. I would also learn Mahout. So I will give Mahout in action book as well as the recommendation. So it's not based on the user. It is based precisely on an item. So that's an item-to-item recommendation. But if you look at it, these are not just going to solve all your problems of recommendation in in the real-time world. So you will have to use some advanced concepts like matrix factorizations and other things to really bring in more additional enrichment in this recommendation. So we are going to cover some of those techniques which helps you give an effective recommendation. So that's precisely which we will look at in a recommendation example. We will take one use case, maybe taking a sales data and trying to predict what would be uh, the users who are going to buy next, or an item which is going to be bought, assuming the user has bought a particular item. So those are certain things which we will do as an example with a live example on Mahout to demonstrate the recommendation aspect of it. And we'll use that demonstration using a MapReduce program. The next thing which we will look at is how do you cluster the data. So So clustering data is pretty much another set of problem. So you go most from a outlier detection is one thing which you would really want to. So let's say you are trying to do a fraud detection and you want to find out what are the transactions which are not as per the normal pattern. So after you cluster it, you can group all the items which are similar to each other, and then you find out which are not really similar and use that for detecting your fraud. So one of the techniques for fraud detection is an outlier detection, and clustering helps you do some of those. It's basically trying to group things together. So you could actually cluster textual data as well. And let's say you are taking all the news feeds in the world and you try to cluster it. So you could actually cluster it saying that, okay, these all news belongs to this particular subject area and so on. So these are real examples which people have used for clustering. So we could do some of those examples and see how to implement clustering in Hadoop. The other aspects which we will cover during this process is how you could actually convert uh, different types of data and be preparing that data for clustering, because that's a huge challenge, especially with data cleansing and preparing the data for clustering. The next one is basically the classification. Again, you could do a lot of different classifiers inside Mahout, and there are multiple algorithms which supports classification. So what we will do is we will try to look at couple of those algorithms and try to build either a sentiment analyzer, okay, or we will build something like a classification of a particular unstructured text. So how can you actually classify certain categories into different values is something which we will look at, and that's going to get you started on the classification aspect of it. Again, going back to last part of it is pattern matching, where you try to find out patterns in data. So one such is the frequent item set mining using FP growth, which is called the frequent pattern growth algorithm. And what we would do is how you could actually look at weblog data and find out what are the frequent patterns which occurs in that weblog where the user actually got converted and bought certain things. So how can you increase your sales revenue using weblog analytics on your log data? That's one example which we want to cover. Beyond that, we will see if we have some time, we will look at logistic regression in Mahout, and how you could actually cover logistic regression and other things in Mahout. So that's the overall structure of the course. So it's going to be a mix of both theory as well as hands-on with respect to different classification, clustering, pattern matching, and recommendation algorithms in Mahout. And we can also look at what are the fundamentals which you need to do with respect to Mahout. So that's the course content introduction. So if you have any questions, we can take now, and I will proceed to some details around the individual aspects of the content itself. Okay, great. So basically, once you are done with this, I think after this, the idea is that you should be able to pick up any Mahout algorithm from the toolkit itself, because many of them are not documented. We will show you how to navigate through the code and show you that yes, if a new algorithm comes into Mahout, even if there is no documentation, how can you go about and really start working with that algorithm. So that's the thing which we need to really reach at the end of this course, because beyond that, then everybody can do their own machine learning using Mahout. So the focus is to reach to that stage. Okay, so let's look at some few introduction to machine learning while we get into some of the concepts. So some of the frequent examples which looks at machine learning is your spam folder in Gmail. So So how does Gmail or Yahoo be able to identify which email is spam and which is not a spam? So, so the whole idea is that they try to classify the messages which comes to you under these spam and not spam class categories, and use machine learning to do that. So as the mail come through, so they have a model which is based on their training data sets. They have already trained and created a model which says that these are the historically what has been classified as spam. And if that is the case, then when a new email comes in, it is passed through that classification algorithm to figure out which category it belongs to, whether it belongs to spam or non-spam category. And accordingly, you get the classification done. So we will look at this example as well and see if there is any way we could actually model any classification examples. The second way to look at it, what is a recommendation? We can look at the Facebook or LinkedIn. So LinkedIn gives you very, very strong recommendation saying that you might also have these as your friends, or you might know all of these as guys which you know about. So bringing that network information to you and saying that, yeah, discovering that relationship and telling it to you, saying that, yeah, this is a guy whom you also would know and you might want to connect, is a good recommendation which LinkedIn gives you. And if you would have seen the outputs, it's really impressive that the recommendation given is something which you would always go and click. Similar is the case of Facebook. So identifying all your Facebook friends is another example where it is giving you some amount of recommendation and saying that, yeah, this user seems to be similar to you and he has been doing something similar to you. So that is one. But if you look at it, both this LinkedIn and Facebook is not just using recommendation itself, it is using the network also, network relationships as well, and that's how it starts from getting the recommendation. So yeah, what I was mentioning is that, yeah, they are trying to find the user similarity and trying to get the based on the user similarity, it is trying to recommend it. But if you look at deep into these recommendations, they are pretty sophisticated recommendation, and they just don't use one single techniques. They use the network relationship also to derive the recommendation. So they not only look at the users details, but also look at the network of the users and accordingly model the users. So modeling a recommendation is very tricky in these cases. So, so the other example which you look at it is, see, handling big data through data processing is one aspect of it, but taking that data and converting that to insight is a very big challenge. So how do you take unstructured data and make intelligence out of it? So clustering gives you one very good technique in understanding the data itself. So when you don't know anything about the data, you just load it into, let's say, Hadoop and say, I don't know anything about this data. Can you tell me something? What can I start investigating on this? So one of the essential techniques which you have is clustering. So you cluster the data, it will start automatically. So clusterings are both automatic clustering and trained clustering. So I will show you what does that really mean in the next slide. So once you give the piles of data to this clustering algorithm, it will cluster and say that these all documents are similar and this is the category around it. So you could actually do automated category extraction from the document using clustering and some of the other combination techniques. So the most important thing to remember is you need to know all these techniques, and then it is a combination of these which actually gets results. It is not usually saying, okay, I'll just do clustering or classification and I will get an output. What I've seen it is you usually use a combination of these techniques because these are all fundamentals, and once you get the fundamentals right, you use this to the best of it, and it might be a multi-stage machine learning where you do and finally get the output. So let's look at a weblog which is coming through. So a website is there, and I have got just pure weblogs of that data, and I'm seeing that sometimes for some items the sales are going up, for some items the sales are going down. I want to find out what is the pattern on which a user comes in and he always goes and buys it, so that I can redirect all my navigation in that style so that the user actually buys it and my conversion of sales increases. So just looking at the weblog data, you will find a sequence of events which the user goes through pattern mining, okay, and saying this is the pattern of the most users who actually bought a particular item or who actually gave me some business. While there are other navigation paths which people have come through and they have not really yielded anything. So let's say somebody is coming through price grabber, and most of the time he has come through price grabber, but he has not really purchased anything. So the referral part was price grabber or something like that. Well, you saw that always a referral coming from Google was a person who actually got converted majority of the time. So the moment you get some information like that, then you know what your actions you need to do on your website to really fine tune it. So to identify which users has really caused it or what is the pattern, you need to do pattern mining on the data. So to do any analysis in weblog, first you need to sessionize it, or you need to bucket it into sessions, and then you have to understand and study each of the sessions, and then try to build a relationship or patterns between these sessions. Okay, and then you have to classify each sessions into such a way that you find the most patterns which are going to get converted. Okay, and then from that list you will also find out which are the patterns where conversion is not really happening on the data. And then you dissect the whole problem and say that yeah, these are the behaviors where users are usually getting converted. Okay. Now you can apply the same technique in something else as well. So we were working with some of the other customers, and what we saw is that the customer gave us a transaction list and said, these are my transaction list of my customer, my database, and this is the particular outcome. So whether they have actually invested more money in my company or they have taken out some money out of my company. So these are the kind of analysis they have, the data they have provided. And then they said that with these transactions, can you find out which of these customers are most likely to add more money going forward, and which of those customers are going to take away my money from my firm. Okay. So that kind of analysis you could do on the data which is not even unstructured. It is purely structured, but doing pattern mining on that data, you could actually figure out that yeah, these are the kind of behaviorals which actually results into a user disinvesting in your firm basically, or these are the conditions on which the user is going to invest on your firm, and so on. So the key construct here is that the possibility is endless. The possibility is endless. Let's take another example, just purely with the social data. Okay. So one of the thing is which we can do is we can do some analysis on the, let's say, on the social data, and with that social data and correlating that with the economic data. Okay. So let's say the inflation data or the job data, you could actually find out whether a particular sales of a particular brand is going down or up. So because you get the quarterly reports of all these companies, you can use a model, create a model using the social data, the economic data, and other open data which is available, and try to establish if there is any correlation between a sale of a particular item and these other external influencing data, and then may be able to predict it, saying that yeah, if these are the characteristics, yeah, this is what the sales is going to look like. It might not be a very strongly dependent data, but yeah, it's still will give you lot more insight on what you could have not got earlier. Okay, so these are some of the examples. So now let's go ahead and check few things. So what is really machine learning, and then we look at what is supervised learning and unsupervised learning.
Okay.
So from a machine learning perspective, it's basically telling the computer and about the previous experience or data, and saying that, yeah, if you know about all this previous data, can you tell me based on this new data what is going to happen? So that's precisely the construct. The construct is you feed all the previous historical information to the computer, and it is going to derive some sort of relationships based on an algorithm. So you would also decide the algorithm which the machine has to use for learning, and then once the machine learns that, then you give a new set of data and say that, yeah, this is the new data which I don't know the outcome. Can you predict the outcome? So what machine learning algorithms usually does is it tries to find the probability of how much probability does this event is going to give you to create this particular outcome based on the historical data. So it is doing a lot of analysis, both probabilistic and categorical, and trying to give you some output. So that's the fundamentals on machine learning. So let me give you one small example. 1 second. See, this is basically this is the basic step, okay, which happens in any machine learning. So what happens is you gather all the historical data, we put it into Hadoop precisely. Now, traditionally, people couldn't have processed large amount of data. So what they do is they take subset of this data and process it and create models. But there is one fundamental rule is that the model accuracy depends upon the volume of the data which you give it to it.
That's right.
So the more volume you give, the model accuracy improves it. So which essentially means with big data, we have a very high probability that we can improve the accuracy of the model because we can process large volume of data. Okay, so that is the reason why machine learning and big data falls something which goes hand in hand, because the accuracy of machine learning depends upon the volume of the data which it can be used for modeling, and big data processing technologies helps you do that. Okay, so the steps which you follow in any machine learning is like this. You gather the data, then within the data you identify what is known as features. So basically features are like the characteristics on which you want to start looking at. So let's like the social data. Okay, social data, you can say that I collected lot of social data. It's lot of unstructured textual data which is there. But with that data, can I really use it for any prediction or any calculation? Yes. Before doing that, you need to identify the features from that data. So what data features could you look at? Let's say you are looking at the analysis of an auto industry. Okay.
Right.
So if you are looking at analysis of an auto industry, first you need to find out what are the characteristics of the auto industry. So one of the characteristics you will see is the segmentation of the vehicles. You'll say some of them is hatchback or some is sedan and so on, right? So you have to uncover those dimensions from that. So what you would do is you will parse the text and identify these different dimensions from the data. You'll identify the brands which the user is talking about. You will try to find the segments on which the user is talking about. You will also look at find out which is the gender which is talking about, then which is the area of location, basically which geography it is talking about. So these are different dimensions which you can extract out from the data, and then you can say whether my prediction which I want to do will basically depend on any of these extracted dimension or features. Okay. So that is the second step. So you actually go ahead and do this identification. So even in a recommendation, before you do the final recommendation, you have to identify on what feature you are going to say that the users are going to be similar.
Sure. Okay.
So if you are doing a user-to-user similarity, you are trying to find out what dimensions or what features you will say that these two users are similar. So that is the
Sure.
first construct. Okay. So if you are doing an item-to-item similarity, again you will say on what construct the items are similar. Is it a usage of the item is going to be same, or is it going to be the domain in which the item is used is going to be the same, or and so on. So if you look at the user, the characteristic of the user, like where the user lives, is it where is he geographically located? If he's a US based user, then maybe again we can look at segmenting it by state as well, because a certain
Right.
specific state or certain area would actually have more relevance to certain things. So you can define based on your problem statement how you would classify the user. Okay. And categorize the user. So you identify that features, then you prepare the data. So you basically extract the features out of the data and prepare it for things. Then you run the algorithm. Usually the algorithms run in two steps. So it goes like this. So you have prepared the data, you run it through the learning algorithm and create what is known as a model. Okay. Then the second thing is when the new data comes in, you don't know what is the categories. This is all question mark. You pass it through the model and it will tell which category it will belong to or which recommendation it will give to. So most of the algorithms fall into this category, where based on the previous data, you run an algorithm, create a model. So you basically create what is known as training model. Okay. Then use that model for doing the prediction. Now, this kind of model is called as supervised training, supervised learning basically. So what is supervised learning? You have actually given earlier data set where you know precisely what the outcome was and try to create a model. Okay. And you are trying to predict when the new data comes in. While in unsupervised learning, you really don't have the previous set of data. Okay. Example which I gave with the pile of data you got which are unstructured data. Okay. So let's say I give you all sort of social feeds which you got, and you don't know anything about it. So I can blindly run a clustering algorithm on it, and it will automatically cluster into groups and gives me saying that this is all chatter about auto industry, or this is all chatter about some other things, and so on. So if the algorithm itself can, without taking any particular input, can itself figure out, okay, and classify and cluster this together, that kind of algorithms are called as unsupervised learning. So I have some slides on supervised, unsupervised.
So
Then we will have to go more details into vectors and other things.
okay.
Yeah, so this is what about supervised, unsupervised learning. Okay, so making sense of the data without any examples of what is correct or incorrect. So you really don't know about the data at all, and you're just giving it to the algorithm. So that is what is unsupervised learning. Okay, while in a supervised learning, you already know it. So one very good example is a handwriting detection algorithm. Okay, and we can use that one of these algorithms to actually detect the handwriting. So because you train it in saying that if you write A like this, it's called A, and so on. So you keep doing this practice and giving it to the algorithm. So algorithm try to find the patterns around that which you created, and then it tries to model it and create the input model for it. And then when the new data comes in, it tries to classify. Okay. So that is what is known as supervised learning. Supervised learning, you already have a history and you have the labels assigned to that history upfront. You know the outcome basically on that training data set. So the more data set like that you have, it will be useful. It is usually used in fraud detection. In fraud, you precisely know in history, these are transactions which I have paid and there were frauds around it. Okay. while all the other transactions were there where I didn't really knew they were fraud. So now you know precisely how you could create a model, okay? And you can create a model with that. And then when the new transaction comes in, if it is any of this previous history, it will immediately flag it off. So this is all about supervised and unsupervised learning. And tomorrow, next class, we will go about in details around vectors and other things. So since this was the introduction, I will rather stop it here. So the whole thing is to give you the glimpse of what is going to come through in Mahout, and accordingly we can take it forward.
Okay, sure. A couple of quick
Machine
questions.
learning algorithms. Okay. One such algorithm, machine learning library is Mahout. But there are machine learning algorithms implemented using machine learning libraries called VEKA. W-E-K-A. Okay. The problem with VEKA is that it is not scalable in the sense that it is not parallelized on a distributed computing infrastructure, and people have been trying to do some of those. So that is one another machine learning libraries toolkits which you have. Lot of machine learning algorithms exist in SAS and R. Okay.